Good afternoon, everyone, and welcome to the HamSCI Telecon. So today we basically want to see if people have information on the Tonga event so far, and just see what people have, and we can discuss it a little bit. And we'll go from there. I have to admit, me personally, I've definitely been interested in this, but I haven't had nearly enough time to actually look at the data and digest any of it myself. So I am not nearly as prepared as I would like to be for this. So I hope that other people might have some suggestions. I can certainly point people to some papers and resources that have already been done, and maybe we can come up with a plan together. So we'll go from there. I guess before we get started, do we want to let's see, do you want to go around and have a quick round of introductions and say what people are up to so we know who's here? So I'm Nathaniel, W2NAF, and I've been very busy working on the getting the HamSCI conference workshop ready to go. We got the LSTID, large scale traveling atmospheric disturbance paper, published last week. I've been trying to manage student projects and things like that. So that's what I've been up to. I guess we'll start, I guess in order of my screen, we'll go to Bob, WK2Y.
Good afternoon, everyone. Bob in Atlanta, retired statistician from the Centers for Disease Control, and no, I know nothing about COVID. I was in chronic disease. I have been busy crunching numbers and getting my slides together for the HamSCI conference that I will be presenting at virtually. And banging my head against the wall trying to get access to the servers that Nathaniel now has, but for some reason the secure VPN utility that Scranton makes one go through doesn't like my desktop and cuts off my internet to start. And we don't know why. I also got bumped off of Amazon Web Services, Nathaniel. They just finally gave up on me altogether. So that's not going to be, after giving me the $1,000 credit, they stopped talking to me. And then let's see what else is going on. I joined the Long Island CW Academy. If you don't want email, do not join the Long Island CW Academy. But if you want to learn CW, it's a lot of fun. They got a lot of different ways of doing things. Back to Ned.
Thank you very much. Let's go over to Mitch, W2MDE.
Howdy, howdy. Thank you much. Name is Mitch, located in beautiful Hackensack, North Jersey. And I am a lurker and a sponge. I'm trying to glean as much as I can from you guys as possible. Just recently started playing around with the great demo program that you were kind enough to go through, Nathaniel, last couple of weeks. Grabbing some data. I don't have a great grabbing some data off of FLDigi and running it through the data analysis program that you you showed to us, and just trying to get familiar with Python, Jupyter Notebook, so on and so forth. I'm here to learn as much as I possibly can. I'm not part of a brain trust like you guys. Retired clinical data analyst and just a curious curious mind.
Thank you very much, Mitch. And I'm sure we can get someone to give you access to lots of grape data if you'd like to have real grape data.
Sure, absolutely.
Great. So I think we'll hand over to John, NAOBJ.
I'm John, NAOBJ. Came into this project more of a hardware designer. I designed the Grape 1 as a proof of concept, which unfortunately worked too well and got distributed. I know I keep harping on that, but it really wasn't supposed to go out. Working now on the Grape 2, I've got the RF distribution app working. I've got the other interfaces going. The quad radios work. Well, I got parts of the quad radio working. I have to work on the clock tree. And right now I'm trying to wrap up the engine that actually does the data collection automatically, that self-synchronizes itself to the one PPS GPS signal, and resyncs itself every second and auto loads itself every second and runs in the background on a Raspberry Pi such as once you kick it off, it automatically collects the data and then puts it into the file format, which is up on the HamSCI GitHub repository on the file format for that. Also modified FLDigi originally back in 2019 to create the file format that I wrote the document for, and it is being uploaded to our repo now that WWV Amateur Radio Club is graciously granting us. Actively right now, I think I've got 8 of the 37 nodes auto uploading, so I've got some more work to do. I'm pushing on people to do the auto uploads, Nathaniel. I'm a hardware designer or an analog hardware designer. I worked at Keithy for 20 years, and I dabble in code and rely on people like Bob Benedict to straighten me out when I get screwed up. So that's me in a nutshell. Back to Ned.
Thank you very much, John. I appreciate it. Over to Gary, AF8A.
Good afternoon, everyone. Gary, AF8A here from Cleveland. I'm also retired EE, a Case graduate. I spent most of my working career as a middle manager in a large manufacturing concern. So my technical skills on data analysis and circuit design and software and stuff there are all pretty rusty. But I have to say I appreciate that HamSCI has kind of given me a little focus and brought me into the fold a little bit. Just today I started building a surface mount QRP rig, first surface mount work I've ever done, even though I've been a ham for 45 years. And finished a recent series of like 39 YouTube videos on fast Fourier transforms. It all helps me understand what's going on in this and the other forums. So I appreciate the opportunity. Back to Ned.
Thank you, Gary. That's great. Over to Mary Lou, KC2NMC.
Hi there. So I've been working with Nathaniel for many years. I'm from Montclair State University, New Jersey, retired physics professor, astronomy professor, very interested in the Earth as a whole planet and also in exoplanets, which is where I do some work. Good to see you all.
Thank you, Mary Lou. Over to Dave, W60Q.
Okay. Yeah, so I'm in Los Angeles, sort of a lurker here trying to figure out, where I can be helpful. Not that I have a lot of time right now. My daughter's getting married in June, so I'm been keeping busy. Mostly hardware. Worked at consumer electronics through a long career that I'm retired from now. So pretty good with the smaller stuff and RF and some microprocessor stuff. So that's the resources I've got.
Great, thank you very much. And over to Ward, WC0Y.
Good afternoon to the group. I'm a retired electrical engineer. My career brought me to Fort Wayne, Indiana, where I am now. And I recently set up Grape version 1. So I think I have it operating in a stable manner and auto uploading every day. I'm also known as node number 38. So back to Ned.
Thank you very much. Next, let's go to Aiden. KB3MD.
Hi, can you hear me?
Yep.
First time zooming on a new computer. Yeah, so hi everyone, I'm Aiden, KB3UMD. I am an alumni of the Case Amateur Radio Club from Case Western in Cleveland, Ohio. I just graduated this past year, and I am soon to be a new electrical engineer at NIST in Colorado. So I no cool NIST background yet, but hopefully in a few months I'll have some cool things to show. So I'm quite excited about that. I'll be going out to the land of WWV and all good fun things there. So yeah, that's me.
Congratulations, Aiden. That's wonderful. Okay, Ron, KF7ZN.
Well, hello, everybody. I'm a fairly infrequent guest here as I usually have meetings on Thursday afternoons, and so I cannot get on very often. I started with Mountain Bell and AT&T, and then with all the massive layoffs, reinvented myself and became a nurse, and I'm currently a nurse case manager, probably work a couple of more years with Intermountain Health. Living here in Utah. I am definitely a layperson when it comes to all of the different things that some of you professors and scientists, whatever other terminology would be appropriate, absolutely fascinated with this. I actually do love to do presentations, and I actually have one on the sun and the ionosphere that I've done through clubs and different places, but it's strictly a beginner's. So I'm just one that's hoping that there's some small role as this rolls forward that I can contribute or do or help. And if nothing else, I'll just continue to watch and listen. I'm very, very active in the ham radio hobby in a lot of different areas. But other than that, I think that's all I've got. So back to you, Nathaniel.
I think that's great. And actually, you say it's a presentation just for beginners, but I think that's actually something that's very needed. I can also tell you that we've actually received criticism from NASA for not being beginner friendly enough. So
really, well,
yeah.
what I found is I was doing presentations, and I've done them all the way from Zoom, of course, but from the Midwest, the South, and then here in my state. But I would have very experienced ham radio operators that would listen to some of our incredibly talented people like Carl K9LA and Frank and others, and they would come out and they would kind of grasp it, but they really would not understand the basics of the ionosphere and the regions, or what is it really is a CME, and how does the geomagnetic field around the Earth, how does it really impact things? And so that's where this came from. So far it's been pretty well received, but yeah, I'm just trying to help people build a base for the the experts.
Yeah. So I mean,
I have a question.
Yeah.
Ron, would you be willing to give your presentation to an astronomy club in northern New Jersey in the summertime?
I would be willing to do it anywhere. I just want to make sure you know that I'm a medical specialist who
That's okay.
loves
this. For June. We really need a speaker for June.
Yeah. If you go on to qrz.com, you can find my email and all my information under my call sign, and we can do that offline. And anytime I can help or anytime I can learn. I follow Dr. Scove quite a bit, and a lot of the stuff on the HamSCI, try to read it. So I don't want to take too much time, but sure, would be glad if it would add value. I would be glad to do something like that. Yeah. And you can look at it and see more about it and see if it's really something you want or not. I'm also doing it at the QSO Today convention.
That's really great. Thank you. I think it's wonderful. And we'll go over to Steve, WA5FRF.
Okay. Good afternoon, everyone. This is Steve. You can blame Bill Wiles for me. I guess it was in 16 or 17. He was talking about the eclipse, and I asked him, hey, what can I do to help? He said, well, do you have a WWVB receiver? I said, no, I think I could build one. I spent a career developing instrumentation systems for Southwest Research, and that's the kind of stuff I did, was design things to sense and measure. So I did. Got some interesting amplitude data, beautiful eclipse response from WWV down here to Texas, even though that whole path was south of where the eclipse was. It really affected the ionosphere, amplitude-wise anyway. And then later, I got interested in these frequency measuring tests. And, you know, as I was coming up as a young physicist, I knew how painful it was to make a frequency standard that was good to many significant digits past a decimal point. We had one at Southwest Research. It took an entire lab and 4 guys dedicated to it to keep it running. We had a primary frequency standard. And so WWV has always been a fascination to me. And now you can get these GPSDOs. My gosh, you can buy one for a couple $100 and you got the same thing that was enormously difficult that long. And then to find out that just over a skywave path, that extremely stable frequency moves around by 1 or 2 whole hertz out of you know, when the true accuracy is many decimals to the right of that, just drove me nuts. So I spent a lot of time trying to figure out what was causing all those things. So, and then somewhere along the line, I met a guy named Nathaniel, and we've done some fun things together.
Thank you very much, Steve. Appreciate it. Over to David, 88Y.
Sorry, I'm head down grading papers here and really haven't been following things very much. If you were, and I just logged in, were you just asking for a quick introduction?
Yep.
David Kasdan, AD8Y here, Case Western Reserve University, Cleveland, Ohio. And yeah, Nathaniel and I also have done some fun things together. I think I'll leave it at that for the moment.
Thank you very much. Over to
Okay.
David. Over to David McGaugh, N1HAC.
Hello, David, N1HAC, and product of Dartmouth and Princeton physics, and then was working in pro audio for a long time. One of the primary designers of the Synclavier synthesizer and recording system, and then various other pro audio products. And then applications engineer for analog devices for a while, and then got involved with the plasma physics group at Dartmouth, which I've been at for quite some time now, doing ionospheric research with ground receivers, rockets, and balloons. It's a good thing that I like cold weather, because I've seen some real polar conditions, including South Pole, where we have instruments. And right now working on a receiver system for Baffin Island, which is magnetically conjugate to South Pole, and working on a presentation for HamSCI workshop on the broadband loop receive-only antennas that we use. And also I'm a research engineer also for NGIT right now, working on a solar power system for Antarctica. So I guess that's sufficient. Back to Ned.
Thank you very much, David. And over to Mike Neruda, AA8K. And he says his Zoom client is not allowing audio or video at this time. Well, greetings, Mike. Hope you're doing well. Thank you for joining us. And next we'll go over to Michael Wan.
Good afternoon, Michael. Howen is the way you pronounce my last name, but don't feel badly. Everybody butchers it. I've been a ham for quite a while. My first call sign was Alpha 24 Juliet Hotel down in Botswana when I was a Peace Corps volunteer several years ago. I'm an emergency department physician, was director of the ER here locally for a while, but now am cutting back to half-time, and so getting back more into ham radio. In 2017, I participated with, I'm blanking on his name, but we used some whispered data in association with the eclipse, because my location, along with several others, were right on the path of totality. And so we were gathering some interesting data, both from stations in the path and off path. So I'm kind of interested in learning as much as I can from people who know a lot more than I do, and helping where I possibly can.
Thank you very much, Michael. It's a pleasure to meet you. Glad you could join us. And
Greetings from another RPCV, 9N1 land, 7679.
Very good. I was in Botswana 77 to 81.
And next I see Jim K4BSE joined us. Jim, do you want to say hi?
Greetings. Sorry I'm late, but that's me.
That's okay. Welcome. All right. Did I get everybody?
Well, I do want to mention one thing. My son is at Case as a freshman. So I remember when we first visited there, I paid attention to the presence of the antenna up on the roof. I get, must be the ham club there, but it's interesting to connect Case back to some you guys as well. So
Yeah, we're in the process of
Maybe.
replacing that entire tower structure. It's going on even as we speak, and it's been going on now for 3 years. So, but yeah, we're getting there.
very good.
Also,
Thanks.
I grew up in Cleveland and went to Case for some special things as a high school kid. It was great.
Well, that sounds great, everybody. So Tonga, we had the Tonga volcano. Does anyone have any data or would like to talk about it? I know there's at least, 2 or 3 people on here who I think have some things to show. Who would like to start?
I think I've
Steve.
showed my composite data already, and I've got some ways I want to analyze it, but I've just been snowed under.
That makes sense. Maybe, I don't think, Steve Serwin, you have some things to show, right?
Didn't have anything for Tonga. I did start recording some 10 megahertz stuff right about the time that those solar flares hit that downed the Starlink satellites.
Okay.
And there did seem to be, well, it's hard to tell. I recorded data for the entire month after that. And I can tell you that the fluctuations that you see, standard deviation, whatever you call it, the meanderings, the frequency meanderings at 10 megahertz are much larger now than they were 3 years ago. And I think it's just because we're moving up on the sunspot cycle.
Mm-hmm.
They've gotten larger in the year I've been tracking it, slightly less than a year.
Yeah. So it's hard to tell whether, when I looked at this thing, I saw, oh my gosh, the solar flares are really stirring things up, but it didn't really tame down. It stayed maybe a little less, but still pretty active.
Yeah, we've had a number of very active days recently.
Interestingly, I don't fully understand the full frequency effects and the frequency dependencies of index of refraction. I know that it's not frequency independent, but what I've seen is that for the lower frequencies, it stays pretty much the same. It hasn't changed much between low sunspots and now. A 10 megahertz sure has. So apparently it's a nonlinear relationship with frequency. It's interesting. I haven't studied up enough on it though.
That sounds great. Would you like to show some of that today?
Let me gather some of it together. One thing I noticed years ago, and this was during the bottom part of the cycle, when I made the 3 frequency recordings of WWV at the same time at 2.5, 5, at 10.
Mm-hmm.
The wanderings, here I am moving my hands back and forth, just and you can't see it. The wanderings stayed about the same for all 3 frequencies. Now, if those are Doppler shifts, they should scale with frequency. The wanderings at 5 should be twice what they are at 2.5, and they should be twice again bigger at 10. But at that time, they were not. They were all about the same. But now that we're up on the sunspot cycle, sure enough, 10 megahertz has got maybe twice as much wanderings around as 5. So this frequency dependency kind of depends on where you're on the cycle, it looks like. These are just.
Isn't that kind of strange that it would depend on part of the solar cycle?
That it depend on ionization, which is cycle dependent.
Yeah.
Well, that assumes that the reflection is the same at all frequencies, I think. And I wonder if that's true. For instance, some might be getting reflected off of one layer and some off another at certain times. Well, or at least in different places.
Yeah, during the day, the E layer comes in. And
right.
It's very stable compared to what goes on with the F layer I've seen. So during the night, of course, E layer goes away. Everything's coming off the F layer. Different height, of course.
Yeah, it would be different heights. I'm
higher.
I'm just not sure you can say that say 2.5 and 15 are getting reflected off the same place in the ionosphere when you're seeing both.
Right.
Yeah, I'm almost certain they would not be getting reflected off of the same height in the ionosphere.
Probably not. I've never looked into that.
I guess all I can say is that I've noticed a difference between now and 3 years ago.
Yeah.
I think that sounds really good. Maybe, Jim, would you mind showing your Tonga?
Yeah, I
thing
can.
again, please.
Yeah, let me pull it up again. Now this machine's decided to run slow. It's a Windows machine. What do you expect?
Oh, yeah.
Okay, I'm getting there. It's just taking forever. Is mine up now?
No, not yet.
I didn't think so. I can't get back to you all of a sudden now that I've got it up. Now it wants me to leave the meeting. No, I don't want to leave the meeting. Well, I've got the slides up, but I can't get back into, oh, wait a minute. I know what I'm doing wrong. I've seen this before. There we go. Okay. All right. That's what I want to show. Now are you seeing it?
It's starting. There we go.
Okay. This is what I'd gotten before. This is I've gotten 7 stations, I think, on the day before the Tonga event, the 14th, just as kind of a sort of a control. And then the same ones plus one more on the 15th, the day of. And let me get down here. This is starting the day of. These green vertical lines just every 3 hours to make it a little bit easier for me to read the graphs. The red line is the approximate time of the Tonga event. And I had calculated at one point maybe about a 9 hours to get to us based on some data I had seen on the propagation time of the pressure wave. That's probably a little long. I think it should be closer to 8. And you can see I've got a lot of Ohio stations because they contributed a lot. You can see in that area some stuff going on, but you can also see a lot of stuff earlier in the day. And this is pretty consistent over all the data. There's another Ohio station. You'll notice it looks a lot like the first, which is good. This is a Pennsylvania station, a little bit further. You do see the same kind of thing here. Over earlier in the day, you did not see quite the same thing. This is another Ohio, and it looks like the other Ohio's. Another Ohio, it's a little bit more extreme, but doesn't look like unlike the others. Here's one in Arizona. This one's a lot closer to WWV. These are all 10 megahertz WWV except for one. And this one is different, but he is a little bit, he's kind of close to WWV. So does that make any difference? I don't know. This is mine, and it again shows that the approximate time of the transition of the transit of the pressure wave. It does show some stuff, shows some stuff earlier, not the same as the Ohio, but that's probably to be expected because the reflections are off a different point than the ionosphere. We're definitely seeing some stuff. Now, this is the one that's different. This is Netherlands, and he was monitoring CHU at 14.67 megahertz. Again, we see some things at the approximate time of the effects of Tonga should be getting there. We see some things, but I've had a hard time really being able to stay with any confidence that this is due to the Tonga event and not something else, because we had some other events going on earlier in the day. In fact, even starting, in fact, if you look the day before, starting a little bit before midnight. Now, this characteristic of some sudden rises in the ionosphere shortly after midnight UTC, I see that fairly commonly. Not just these days, but it's pretty common on other days too. This stuff right in here is not common, but well, it's been happening more recently. And so like I said, I'm having trouble really saying with confidence that that's due to Tonga, although it could be. The timing is about right.
Mhm.
So maybe. Best I can say right now is maybe, maybe not. People have suggested some other ways to define it. And I believe on one meeting last week, I can't remember which one, it was stated that one of the definitions of a TID is, well, no, let me take that off the table. These are not TIDs we're looking for.
No, they are. I think these are TIDs actually.
Actually, okay, yeah, I guess you could say, because it is traveling and it is an ionospheric disturbance, just caused by maybe something different. But the definition was supposedly in a certain frequency range. And there's some ways suggested to extract the frequency from this. I have not had a chance to do that yet.
Yeah.
It's going to push me a little bit because it's software that I'm not familiar with.
Yeah.
But that did look like an interesting way to study it.
Yeah, from what you're showing right here, one of the things I'm thinking is there's so much stuff going on right now. It's kind of hard to keep track of what's going on. I think one of the things I might do next, if I were to do this, is I'd try to make a stack plot. So I'd put it into I would use Python, but you could use other things too. But I'd try and make maybe a stack plot where I would put the stations that are closest to Tonga at the bottom, and then I would stack them up so that the stations farthest away are on top. And I'd only plot the Doppler shift data.
Mm-hmm.
And that way you might be able to see coherent wave structures, and you might be able to see them propagate forward in time.
Yeah, that is a possibility. Are there routines written in Python that would do that you can refer me to?
I would have to write it myself. So,
Unfortunately.
but we can look at, and I mean, one thing we can do is we can take some of the time at some of these sessions to do some of that writing and like walk people through how you would go about doing that. And because it actually, once I have the data kind of in front of me, it's not too hard to go ahead and do that. Do you, for these particular, would you be able to do me a favor, Jim?
Mhm.
Do you have all the raw data files for these all in the same place?
No, I don't. I was only sent the graphical
Mm.
data. I can probably go back and request the raw data files.
Yeah, if you can get all the raw data in a folder and send it to me, then I could walk through and show, I could do another data tutorial here where I'd show you how I would go about loading all of that data in and creating, a stack plot for this sort of thing.
That would be great. I will ask the stations who sent this to send me their raw data,
Yeah.
and I can ship that to you. That's going to be a fair amount of data. It's going to be about 32 gigabytes of data. I'd figure out how to ship that to you.
Is it really that much?
The raw data files are about 4 gigabytes each, as I recall.
They're 4 megabytes each.
Yeah,
4
4
megabytes.
megabytes.
Okay,
Yeah, I was gonna
megabytes.
say,
That's better.
yeah.
That's easy. Okay.
No, I was like, I didn't think it was that big because I know I'm collecting this data too, and I thought it was 4 megabytes is, and you only have what, 8 stations or
8
10
stations. Yeah, that's
Yeah.
not as bad.
So, yeah, no,
And
so
at
that
least
should be,
5 of them are in the repo already, so you already have access to them, Nathaniel.
I do. I just have to go figure out how to get the repo. Get to the repo.
FileZilla is your friend.
Yes.
It works
But
really well.
If someone, yeah, no, I understand that. I just have a lot of different repos and things. So if Jim or if someone could put all the files for this particular day in one folder, then I could.
See, I could do that for you if you show me where you want me to put it.
Can you just send me? Can you just put it in a either Dropbox or Google Share link or something? Do you want to do it right now?
Let's see. Let me log in.
While he's doing that, so first of all, Jim, I think this is a really nice analysis, and I think it really kind of shows how messy the data is. Did anyone else want to make any comments or have questions for him? I know Mary Lou often has a good eye for these sorts of things.
I wondered if, so it looks like in this one that we're looking at right now, that there's considerably more variability on the right side after the event has happened than on the left side before it happened. That would be nice to extract that as, standard deviation or something and plot those versus time. Could you slowly scan upwards through the ones that you showed us before?
Sure.
Please.
That's Arizona.
That shows it too.
Yes. And here's one of the Ohio's. And
oh, well, golly, Ohio is doing it all over the place, huh?
yeah, the Ohio's are fairly consistent.
Are they arranged the same sort of latitude in Ohio? Or I suppose it doesn't matter. Ohio's.
Yeah, the latitude's right on the header, so.
Oh, okay, good.
Yeah, these are actually arranged by node numbers at this time. There's a Pennsylvania, which is a little bit different, but
that looks like it was probably Aiden's. Node 8 is David 88Y in Cleveland Heights.
I believe it is him, yeah.
Yeah, the majority of the Ohio stations, if not all of them, are going to be within 40 or 50 miles of downtown Cleveland, probably.
Yeah, Node 7 is me in Macedonia, Ohio, which is halfway between Cleveland and Akron.
Okay. That one doesn't seem to show the variability quite as much.
No, not as much.
It looks equally jiggly on both sides.
Yeah.
I got a more stable antenna.
Okay. Was it a windy day too?
Yeah.
Okay, that's the top one from the date.
Yeah.
Way to tell which ones you're looking at is look for the red line. Doesn't exist the day before.
Now, Nathaniel, you were after just 15th.
I think for now.
Okay.
So it's really hard, but you can see that there are a couple of features here that are more or less the same distance apart in several of them. Well, I'd say less of the same distance apart. I don't know, I've spent a fair amount of time scrolling through these and it's hard
Yeah.
for me to look and see what I've got.
Yeah, I think we're going to have to try to do some things to
Do you have any idea why the Netherlands is different from everybody else other than being far away? Does he have different kind of equipment at all?
He's running a grape, but trying
is
to think if
listening
there's anything else
speed.
unique about his situation. I know his elevation is -2 meters, so he's right at sea level.
Is he the only one on 15 megahertz and the rest are all 10? I'm not sure.
Yes.
Yeah, he's at 14.67. Everybody else was at 10.
So that's a completely different transmitter. I assume it's the same polarization as WWV, but you don't even know that. The radio
Yeah,
waves.
we don't know that for
coming in.
sure either.
Yeah, that could have changed in propagation. Probably did.
And it's over on a different continent, over the ocean in a higher latitude region, and
Right.
Yeah.
all sorts of things. Although magnetic latitude, because the magnetic pole's tilted towards the United States, so maybe magnetic latitude wise, it might not be that different, but we could find that out. Well, while John's still looking for that, do you mind if I share this one paper over here?
Go ahead. Let me get out of sharing.
Can I show you something too?
Sure. Who wants to go first?
Mine is a single slide.
All right, you go, Mary Lou.
Okay.
Nice ace up your sleeve on that one.
Come on. Any rate, what I want to show you is this one, which has really quite a different sort of thing from what you folks are doing, but I just thought it was intensive. So we're looking down from a weather satellite at the island of Tonga, Tonga, and all the little orange and yellow spots are lightning. This is the most intense lightning anybody has ever seen anywhere in the whole world, as long as we'd be keeping records. So there.
Wow.
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 So this
That's
thing
impressive.
shot up. So the explosion was slightly under the water, a couple hundred meters, not much. And it shot up ash and water. So it's wet ash that went up higher in the stratosphere than anything has ever gone before. And I don't remember the number, but all this stuff rubbed on itself and made huge amounts of lightning. So that's the lightning in the, I don't know, first half hour or something like that.
I heard there's a lot of lightning, but I hadn't appreciated how much until I saw that.
Oh my golly. Okay, so it's your turn, Nathaniel.
All right.
Well,
And
a question on the lightning, is it, I mean, we hear about cloud to cloud and cloud to ground. Do we know yet what was typical there? Or
I'm not sure, but I believe it was cloud to cloud.
That would make sense.
Yeah, well, you
That
don't
would
know.
make sense, yeah.
I saw that and went, whoa, I'm glad I'm not there. Reapers.
I was born and raised in Tampa, which is the lightning capital of the world, but it's not that bad.
I didn't realize it was that much lightning. That is impressive.
So that should do something to the upper atmosphere as well, shouldn't it?
Yeah.
I would think so.
Wow.
Over what time period would that be? How long a duration?
I believe it's the first hour or half hour, something like that, but I can't read it now. Anyway, this is what a weather satellite saw.
Amazing.
So
Did you see, have you seen the boom heard round the world 6 times business?
Yes.
Yeah, and did you see the one from O'Hare Airport in Chicago?
Don't remember that
Where
one.
that one is. If I could find that one. This is it. So this is the barometric pressure from Chicago O'Hare Airport, and starts at a random time here. But this first yellow arrow points to this jig-jag, which is the first term they heard the boom coming from Tonga across the Pacific, across California to Chicago.
I guess
And
I'm
then-
not seeing that.
No, we're not seeing it yet.
You're not seeing
Still
it.
seeing the lightning picture.
Huh. Well, don't know.
It looks like it grabbed a screen that's just showing photos.
So here I put the Chicago one on top of the lightning one. Do you still see the lightning one?
Yeah, I still see the lightning one.
Yeah, I think you have to go back to a
Reshare?
reshare
Yeah,
probably.
you're probably sharing the app that has the one photo,
Right.
and not your, not your desktop.
Okay. Never mind. Nathaniel, it's your turn.
all right, thank you. That's really cool, Mary Lou.
Yeah.
I did not realize there's that much lightning. So what I am going to show is this is oh, first of all, before I show this, Gary, someone's asking for the link to your FFT tutorials. If you could just put that in the chat. Okay, and so this is a preprint that's on the ESSOAR preprint server, and this is written by our friend David Themmons, who's up in Canada, in New Brunswick, and he's also a member of the HamSCI group, so he's on our list. And so this is global propagation of ionospheric disturbances associated with the Tonga volcano, and they did this study with the GPS and GNSS total electron content data. And this is submitted to geophysical research letters. And there's a few things that struck me. I'll just point out a couple things here. So on this map, they're showing the red dots show the location of the GNSS stations used in this study. The blue boxes show particular regions that they look at more carefully. And these concentric circles, this is distance away from the Tonga explosion. So I believe the Tonga explosion was over here. And so it says that these are 1,500 kilometer steps away from the explosion. Each of the ones that are marked off with little X's, those are the GPS total electron content measurements are plotted up here in black. So here's the ones from New Zealand, here's the ones from Australia, here's Japan, Eastern Canada, South Africa, Northern Norway. And the red lines, they did some modeling using a, I think it was modeling the water height. So they were modeling the pressure wave. And so that's overlaid on top. So you have the results of the model overlaid on top, and then the results of the actual measurements from the ionosphere below. Now, one thing that, let me jump ahead to another plot here. This is just looking at New Zealand. And this again is showing, this is deviations, where the differential total electron content with the background removed as a function of time and distance from the eruption. And the reds are increases in electron density and blue is decreases. And what you can see is shortly after the eruption, you can see these large scale traveling atmospheric disturbances propagating away. And then it changes. The wave structures change from the large scale to the medium scale. So you get these like more narrow zebra stripes. And the slope changes a little bit too. So you have an initial response of large scale traveling atmospheric disturbances, and then a subsequent response that goes on for much longer of the medium scale ones. And the other interesting point, aside from having these two different scale sizes of traveling atmospheric disturbances, is they don't propagate the same way. So the large scale ones seem to propagate more in a north-south direction, or they actually say kind of along the magnetic meridian, along the magnetic field direction, but they don't propagate well in the east-west direction against the magnetic field lines. Whereas the MSTIDs propagate omnidirectionally. So you can see that down here, where like here you have New Zealand, you get strong LSTIDs, but if you go to the west in Australia, they're heavily attenuated. And they show that in some others, but you can see the MSTIDs there. So some of the things I got out of looking at this is, I think with our GRAPE data, if we organize it in such a way that we, maybe do this sort of thing where we organize it as distance away from the epicenter and we do the stack plots, we might be able to better see the progressions of the waves, kind of like you do over here. And similarly, we might be able to line up, I think they do have some, well, here they have Eastern North America. We might be able to see some of our observations line up with what they see over here as well. And that might help us to confirm that these particular waves are actually from the Tonga event and not from something else.
Nathaniel, can you send me a link to where you want me to put the files? Because I've got them all.
Sure, I can do that. I have to.
No,
I actually I have created a Tonga folder on my computer here on my shared drive. So if I go into here and here and here, here's the Tonga volcano. So I can create a new folder and I can say Tonga GRAPE data, and then I can just share it with
just put JCG66 in there.
JCG66.
There I am, right there.
There, a case, and you can edit and you get notified, and I can hit send.
And when you send that, I will upload it and let you know.
And I can do
pretty quick here.
What I can do for everyone else in case you want the data right away.
Got it.
You got it? Great.
Got the link.
I can share with everybody. Copy link. Chat. So there, if you want to download that data, you can. And here, I'll put a link to this paper in the chat as well.
The information in the chat windows get saved as part of the recordings?
It does.
Okay, that's really useful because the recordings are very helpful.
Yeah.
From time to time. If the chat info is there, it's even better.
It is. The only thing is the way I do things right now is the chat information isn't generally available because I pretty much just upload the videos to YouTube. So the chat ends up staying on my computer, and I don't really have a good way of sharing it right now. But we can. So
Okay,
for now, I'd recommend.
It's all up there.
Great. For now, I'd recommend
That's
just
7 stations worth.
copying the chat and saving it to your local computer. So I think we're getting to the top of the hour here. So I think this is pretty interesting though. And I think what I might suggest for the next, few sessions that we have of this HamSCI Telecon, maybe we keep focusing on this and this event and also similar events like I know the one that Steve Serwin is working on. And maybe we just try to keep working up the data analysis.
I did pull up 3 pictures. You asked me to try and see if I could find some.
Yeah,
really quick.
let's see them.
Let's see. Would desktop work? You see pictures here?
Yep.
Yeah. Mm-hmm.
Okay, you see this one over here on the left? The
Yes.
3 traces? Okay, this was 2019. In fact, it was October the 11th of 2019. This is 2.5 megahertz, 5 megahertz, and 10 megahertz. So if you look at and this is a morning transition. So all of these swings to the right here is when the sun comes up and the ionosphere lowers. But if you look at what's going on before that at night and look at the amplitude of these variations of the turbulence, if that were truly Doppler, Doppler's center frequency times the ratio of velocity divided by c. So it should scale directly with center frequency, and clearly it doesn't, at least back in 2019.
Mm-hmm.
Flash forward to a few weeks ago, and this is 10 megahertz, whereas before this was barely moving a few tenths of a hertz. This is 1 hertz across here. Now we see a full hertz, sometimes both ways. Here's another one. This is a morning transition. Lots more turbulence going on. So big differences in 3 years, unless this is still the ionosphere settling down from that huge solar flare event, which is, we're almost a month out of that now, 3 weeks anyway.
Yeah, I wouldn't think, at least from a solar flare. If it were a geomagnetic storm, that would be a little longer, but.
So anyway, I had recorded a bunch of these things from right after the solar flare up until I cut this off Sunday. I needed my antenna back to do the 20-meter QCWA net.
Yeah.
But anywho, interesting. It may be sunspot cycle dependent stuff.
That's really cool.
Here's some of your, there's a lot of things in here that could be your TIDs.
Wow.
Wow.
Especially see these at 10 megahertz where the solid track just wanders around, like right here all over the place.
Mm-hmm.
Would that be a candidate for one of your traveling disturbances?
It would be a candidate.
The more disturbing, the better.
Yes.
Boundaries look pretty distinct too.
Yes, they do.
I was glad to see these dropouts here in the middle, because it proved to me once and for all that I had gotten all of the 10 megahertz out of my GPS DO out of my receiver. I had to put an attenuator. First of all, I put an attenuator right on the connector, right in front of the GPS DO, and dropped it down 20 dB because the receiver didn't need that big a signal. And then ran a short cable directly to the back of the external reference in, and it pretty well cleaned it up.
Yeah, I've been suspicious that I had a problem there, but when I killed my 10 megahertz GPS DO, nothing changed. So apparently it wasn't that.
Well, the trick is you just take the antenna off your radio completely. And if you still see the trace, you got a problem.
Yeah, I should have done that. I did remember later, I've got one other 10 megahertz oscillator running in the room here that I should have killed and didn't.
Yeah, well, I figured that trick out the 3rd time I tried it, so don't feel bad.
So I have a question on one of these plots that we're looking at. There's some nice variations off to the right, and they look to be periodic. Can you estimate how much time there is between each of those? Is it half an hour, an hour? What do we got?
This is 1 hour per division vertically and
Oh.
1 hertz per division horizontally.
So they're kind of like an hour, huh?
Yeah.
The one that your cursor's right next to looks like about 45 minutes peak to peak.
Yeah, this is the sun coming up in the morning.
Ah,
These happen every morning, and when the ionosphere descends, when the sunrise comes up, and then at night it goes the other way.
But there's some of them that have a really nice, like 45-minute periodicity.
Yes, that's about what they run. Sometimes they run a little longer. This is an evening transition here. You see it swings to the left instead of to the right.
wow, that looks like about 15 minutes on the,
Well, this is an hour here.
yeah, the lower center there.
Oh, yeah, yeah.
About every 15 minutes. Wow.
What about these sharp, well-defined wiggles here? Nathaniel, you think those could be traveling disturbances?
That might be a bogosity
They
wave.
could be.
What kind of a wave?
Bogosity.
Bogosity.
Okay.
It's a new term.
2 hours would be really nice. You get a couple of those.
I'm sorry, what did you say?
2 hours would be really nice, but you don't seem to have any of those.
Oh, a
2
2 hour
hour
wave transition?
2 hour waves are 2 hours of data.
Oh,
2 hour waves.
Well,
What
the
does
2
that represent?
The 2 hour ones would be more of the large scale ones.
Yeah, but you don't seem to have that. These are all smaller ones. Ooh, ooh,
That's getting close.
yeah.
That's an hour and a half of the top part of that one.
and this is morning. So here's 1100 Zulu, which is 5 o'clock in the morning here. So the sun is just getting ready to come up.
That's definitely an hour and a half. That one's
You ever
least
seen
an
a
hour.
2 hour, 3 hours?
Yeah.
Are you using Spectrum Lab to capture that?
Yes.
Oh.
With the, the sample window cranked way up, takes 3.5 minutes to fill one bin.
Wow.
With 75% overlap. So it updates every 45 seconds, but the first one takes 3.5 minutes.
Steve, you only save the pictures of these, right? You don't save the raw data.
Correct.
Is there a way you can start saving the raw data?
Spectrum Lab does have an export thing, and I haven't tried it, but
yeah. Because what we really want to be able to do, like, these are beautiful, but if we want to be able to do anything more with them, we really need the actual numbers in there.
I know.
And otherwise we get really tied whenever we try to go publish things.
Yeah.
Like, I mean, these are gorgeous measurements, but we have to be able to get them. We need to have access to the raw numbers to really do anything with
Sounds
it.
like you need to get a couple of terabyte drive and just start saving data streams.
So, but what would it take? For example, let's draw a straight line right across here. There's a lot of data points. Right?
Well, it's not. I mean, if you're just saving the amplitude spectrum, which is essentially what this is, that's not. And if you're only saving it at, what's the cadence of this?
This is an hour.
Yeah, and then how many FFT windows do you have per hour?
You get a new one every 3.5 minutes.
That's really not that much data. Yeah. Like that is very savable.
But the raw data stream is a 8 kilohertz sample rate.
Well, yeah, but even if you don't have that, even if you don't have like the raw IQ data, if you just have the data that goes into creating these spectrum plots, that's going to be very valuable, and that's something we can work with.
All right, I will look into getting numbers.
Yeah, yeah, we really need to have time-stamped, date-stamped, frequency-stamped data files that go along with this, so that I could load that into Python and replot it. Because if we don't have that, it's going to be very hard to do anything, more than what we're doing right now.
And with Grape 2, we're going to have a longer discussion about this because we'll have the capability of saving the raw data.
Right, which Bill Engelke has done a great job working that up.
Yeah, Yeah, but
But yeah.
we'll be writing our own raw engine because I've got my own A to D system. So yeah, this is the kind of thing that Bob Benedict would be running or writing for.
Yeah. I mean, these are exactly the kinds of measurements we need, but we do have to, we have to have a way of storing those numbers, and we have to have a way of storing them sustainably.
Yes.
Well, can we create a Spectrum Lab configuration which would have the parameters and the data stream you want, and then distribute it to people who could be monitoring these things at different locations?
Well, I think there's two different things going on here, Michael. So one of them is Steve Serwin, who's using Spectrum Lab to make these recordings. I think he's right. I think there is just a simple switch he can click that will save the data file that we need. And yes, for that particular thing, we can simply put those instructions on the website. But for what John Gibbons is talking about, where we're developing, the grape and the tangerine, we're not using Spectrum Lab. We're basically writing our own custom code to run these instruments.
Yeah, we're starting down at the level of the A to D, and I give you a 16-bit hex number, and you do what you want with it. I give it to you at an 8,000 hertz rate.
And I mean, and really
per channel.
The way we're handling it right now is we're basically using a package. There's a package called, we've got a couple tools at our disposal. We have digital RF and we have GNU radio. And I think we're running both of those. And it's really just a matter of deciding when you want to turn it on and record and how much and stuff. But again, it's more complicated than working with Spectrum Lab. But you're right, once we get it set, then everything just gets distributed on a SD card image, and people just run it, and then it won't be a big deal. But it's just figuring out what we want and getting that tuned. Yeah.
But boy, looking here,
I was thinking about
minus a hertz and a half.
Yeah, that's a nice excursion. And because like I could see some of the things you were saying, Steve, now that you're collecting the data over longer periods, as we're going from the end of one solar cycle into the beginning of the other, and you're starting to notice these differences, I think those are really interesting things to be able to write about.
Yeah, 3 years ago, those excursions were a few tenths of a hertz. It's 10 times bigger.
Yeah. Yeah.
That's definitely worth publishing.
Yeah. But again, in order to publish it, we need to be able to have a way of getting at those numbers.
Right.
And then
recreating them.
My time machine project, so I can go back 3 years.
I know. I mean, I think with some of these things, for some of those things, since you do have these images, if we do want to try and, publish on something like that, we could manually get those numbers off of there. It's just, I think it's more of I think if we do have the raw numbers, it's going to be a lot easier to do the processing in the future.
Yeah, for the credibility of the research, you have to have the raw data.
Yeah.
That's the backbone.
Yeah. I think, and I'm gonna have to go soon because I have another meeting. But I think one of the things that I think this is really good for now. So I think those are really nice measurements. If we can figure out how to record those raw numbers and have access to them, I think that'll be really good. And then we don't have a meeting 2 weeks from now for this telecon because that's going to be the week of the HamSCI workshop. So there's no bi-weekly telecon 2 weeks from now. So the next time we will meet on this telecon is a month. So instead of coming to the bi-weekly telecon next time, go attend the HamSCI workshop either in person or virtually. So I hope to see you there for that.
Check your your data box real quick, Nathaniel, make sure that those files showed up in your folder.
Sure, you can. I'm going to check right now. Yep, they look like they're all there.
Yeah, there should be, I think, 7 nodes worth or 8 nodes worth.
Here's what.
Both the PNG file and
yeah, they all are. So what I'm thinking of doing with this over the next few sessions, I'm thinking of working up a data tutorial, and what I've done in the Thursday morning group, I've created a data tutorial for looking at grape data. I called it the grape analysis demo, and you can actually access this. I'll put this in the chat as well. So there is an IPython notebook here, which demonstrates how you can load in the grape data, and you can plot it and then resample it to make sure it's all on an even sampling. And then you can, so now it's on a 1 second cadence, and they replot it again. And then we can apply a bandpass filter to it. So you get rid of, so you basically, it's a smoothing filter. So we're applying a smoothing filter to it. This is, incidentally, this is the same smoothing filter that is applied by the grape automatically when you see the plots on a nightly basis. So the blue dots are the raw data underneath. The orange line here is what you see, like what Jim was actually showing us. So there's already a level of filtering that goes on before you actually see the data.
And feel free to play around with the coefficients for that, because I just played with it till I got something that looked nice. So there's nothing magic about those filter numbers, other than made the data presentable.
And then I show how to filter it some more to get just the MSTIDs. But I think what I might do is I might work up a similar type of data tutorial to show how we can create a stack plot and try to work out the seeing the coherent wave structure move through the system, and it'll make that accessible to everyone. Incidentally, if you go here and you click this launch binder, it will actually launch it in a virtual machine on the internet. So you can play with this on your own, even if you don't have any software installed on your computer. You can run it off of their servers.
In terms of your stack plot, Nathaniel, I would make the suggestion that the vertical axis would be distance from the eruption, so you could see the wave propagate linearly.
Exactly. That's exactly what I was thinking.
Yeah.
All right. I need to go. This has been wonderful. I will see everyone in 2 weeks either in Alabama or virtually from Alabama. So,
sounds good.
Have a great day.
You too.
See you.
Thank you.
Be good.